FA and FB are actually 0. If I put this more restriction, then what it means that A and B are roots of, if fx is a polynomial or fx is any equation, then A and B are the roots of this equation. Fine. Okay. So if you have two roots of this equation, then according to Rolle's theorem, what we have, there is necessarily a point C, at least one point, there may be more than one in AB such that f dash C is 0. So what it means, C is a root of f dash x is equal to 0. And where is this C? C is between A and B, where A and B were roots of fx. So this is the application of Rolle's theorem. Between any two consecutive roots of the function fx, there is necessarily a root of its derivative. Okay, but this doesn't mean that between two roots of f dash you will necessarily have a root of fx. Okay, it doesn't mean that. But it does mean that between any two roots of f dash x, you cannot, between two consecutive roots of f dash x, you cannot have a root, you cannot have more than one root of fx. Why? Why? Because if these are two roots of f dash, okay, two consecutive roots, that means for values between alpha and beta, f dash c cannot be 0, consecutive roots. There is no root between these two numbers. Fine. And we are saying that there are, if possible, there are more than one root of the function f, right? Say A and B. So if f A and fb, these are 0, then applying Rolle's theorem in this interval A to B, I will get one root of f dash. But we said that alpha and beta are consecutive roots. That is, between them, there is no further root of f dash. So what it means? That you cannot have more than one root of the function between two consecutive roots of f dash. Okay. So the some problems can be asked based on this. Please, next slide. Okay. So let's look at this problem 16. fx is product of these factors. If you put x is equal to 4 or 5 or 6 or 7, you will get fx to be 0. That means 4, 5, 6, 7 all are roots. Okay. So if you apply Rolle's theorem on the interval 4 to 5, this function is a polynomial function which is continuous and differentiable everywhere. So first two conditions are satisfied. Moreover, f4 and f5 are both 0 and hence are equal. So by applying Rolle's theorem, what we have, there is necessarily a root in this interval for f dash x. Okay, at least one. You may have more than one. So you have at least one root of f dash in this interval. Now 5 and 6 are also roots of f. So applying Rolle's theorem between this interval, in this interval, you will get at least one root of f dash x in this interval as well. Then again applying in 6 to 7, you will have at least one root in this interval. So at least you have 3 roots. You can have more than that. But f dash will be a polynomial of degree 3, right? So it cannot have more than 3 roots. So what it means? Exactly one root lie in each of these intervals. Fine. So which option is correct? F dash x is equal to 0 has 4 roots. False. 3 roots of f dash x lies in this interval. Equation f dash equal to 0 has only one root. False. D is again false. So which is the correct option? Option B. Okay. The previous above question is question 15. So it says f is a non-constant differentiable function. It is differentiable, so it is continuous as well. Fine, for all x in R. Moreover, it is having this property. Fx is equal to f at 1 minus x. Okay. So first two conditions of Rolle's theorem are satisfied. It is continuous, it is differentiable. Now, Rolle's theorem is not applicable for fx on which of the following options. So in order that Rolle's theorem is applicable, condition 3 should hold. So you have really to check in these four options where FA is not equal to FB. Now, if A is 0, B is 1, using this condition, if you put x is equal to 0, what I get? F0 is equal to F1. So Rolle's theorem is applicable on option A. If you put x is equal to minus 1, you will get f of minus 1 is equal to f at 1 minus minus 1 will make it 2. So f of minus 1 is equal to f at 2. So it is applicable on this interval, closed interval minus 1 to 2 as well. Likewise, you will see it is applicable on minus 2 to 3 as well. But if you put 0 here, you are getting f0 is equal to f1. You do not get f0 is equal to f at 2 by 3. So option D is correct. Okay, Rolle's theorem is not applicable on this. Problem 17, please. So 17th problem is this kind of questions have been asked. Whenever you are given some equation that this like equation of this form in A, B, C, D, this thing is equal to 0. And then you are asked to find that this equation, this polynomial equation has at least this root, right? Rolle's theorem gives you the condition on roots of f dash x, right? So in such problems, Rolle's theorem will be applicable. The only problem is constructing the function and the domain. Fine. So what will be the function? It's integral, which will be fx, right? So what should be fx? Fx should be a function whose derivative is this third degree polynomial. So integrate this polynomial equation. What I have? ax4 by 4 plus bx cube by 3 plus cx square by 2 plus dx. Okay, so fx should be this. Now we have to see what should be the interval. This is a polynomial equation, so first two conditions will be satisfied, right? Now you have to choose your lower and upper end so that f at those points is 0. Now if you put x is equal to 0, each of this term will be 0. f0 is 0. Okay, so we can, one point can be 0. Now what about the other point? That point will be chosen by looking at that equation. What is given to me? 3a plus 2b by c plus d plus 3 by 2 is equal to 0. So if you simplify this, you have 6a plus 4b plus 3c plus 3d is equal to 0, right? Now, if you put x is equal to, what are the other values given to you? 2 and minus 2. 0 is satisfying. So, out of 2 and minus 2, I have to see which one satisfied this condition. Okay. Now, if you see here, all terms are positive. If you put negative sign here, if you put minus 2 here, you will have some negative terms as well. Okay. So, I already have this idea that 2 must satisfy this thing. Then you can check it out. So f of 2 is 16 a by 4 plus 8 by 3b plus 4x square by 2 plus 2d. What? Okay. Thank you. 4c by 2. Okay. So this is 4a plus 8 by 3b plus 2c plus 2d. Then you take LCM. So this is 12a plus 8b plus 2c, sorry, plus 6c plus 6d. And if you take 2 outside, you are left with 6a plus 4b plus 3c plus 3d. This is exactly the expression we had got. Okay, so this is given to be 0. So 2 into 0, this is 0. So Rolle's theorem is applicable on the closed interval 0 to 2. So by applying Rolle's theorem, there is necessarily one root, at least one root of the derivative of this polynomial, which was the given equation. Okay, so that will have at least one root in this. Next problem, please. 18th. Okay, so if f is differentiable, then between two consecutive roots of f dash x is equal to 0. The number of roots of x is equal to 0 can be, tell me, we just discussed this fact. Rolle's theorem says between two consecutive zeros of f, there is at least one zero of f dash. Okay, but then we discussed some result. It does not say that between two consecutive zeros of f dash, we have at least one zero of f, but it tells me that between two consecutive zeros of f dash, we can have at most one zero of f. Why? Should I explain it again? We just discussed it that if these are two consecutive zeros, f dash alpha is 0 and f dash beta is 0. So these are alpha and beta. And if possible, you have two zeros of f function f, that is fa is 0, fb is 0. Then applying Rolle's theorem on this interval, I will again have a 0 of f dash. But then I am saying that these two are consecutive zeros. So between them, I cannot have any 0. That means I cannot have two zeros of f. So either I do not have any 0 or at the most I can have 1. So which option is correct? Option D, B, at most 1. Okay. Okay, so we can have many more problems. And then there are other mean value theorems, Lagrange's mean value theorem and Cauchy's mean value theorem. Those will be discussed in your next session. Okay, good luck.